So let's understand what is this layered neural network. So as we are going into layered neural network, we will try to understand how we can have layer over another neural network layer. S- So many simple neurons are interconnected in form of layers. So as we are talking about a single neuron can do the classification for AND gate and OR gate. But when it comes to XOR gate, where we require a complex classifier, we cannot do with a single neuron. So we require another classifier and another neuron, okay, another layer of neurons which will do the other operation, other task. So each neuron takes inputs from many before, and it provides signal to many more. Okay, so this is how the mechanism works in a neural network or in a central nervous system of a human being, where it takes information from the surrounding and it processes out the information and passes it on to another neuron and something like that. So here we have multiple layers of neurons which keeps on passing out the information from one place to another places. So as in layer neural network as well, multiple layers we require multiple layers, and the functions and weights are best represented using matrices instead of equation. So neural network can represent XOR gate, for example XOR gate line 1 and line 2, or line 1 NAND line 2 we can have, which can separate out the data based on line 1 and line 2, and or if line 1 and line 2 is not there. So we have a layered neural network, in which there are certain terminologies that we need to understand. First is node. So node is each neuron in neural network is called as node. Each neuron is a node. Weights are the signal strengths or importances for that particular input value. So it basically tells us how much importance, how much weightage is there for that particular data. Then we have input layer, where we have the first layer as an input layer. Then we have output layer, which will throw us output. So these two layers are physically connected with the external environment, which is input layer taking information from the environment, and output layer which shows the information to the output world. In middle of all this input layer and output layer, we have different or several levels of hidden layers which are not at all connected with the environment, which are only connected with the input and the output layers. So it acts as a backend for giving out information, and actual processing of information happens in this hidden layers. Now we will talk about activation functions. So a single neuron basically takes an input from the surrounding, and based on this input it gives an output. But based on this input it gives an output. But this output, as it is going to pass, is based on a certain set of processing which is there done there in the neuron. So this processing which is done through a function or mathematical function, and that is called a activation function. So there are several activation functions which basically helps us to process out information in the data. So for this activation function, it may also require certain level of threshold values so as to process the data based on that function. So the first activation function that we are going to see here is sigmoid. So sigmoid activation function is similar to that logistic regression function, and the objective of this function is to either get the data into a sigmoid pattern where it generates a sigmoid equation or S-shaped equation. And sigmoid activation function gives two value, that is either 0 or 1. The formula given is 1 plus 1 plus e raised to minus x, z, where z is basically the input data that we are going to pass, or a linear combination of that input data. So sigmoid activation function helps us to get the data into linear fashion. Then we have hyperbolic tanh function. So hyperbolic tanh function basically is given by e raised to z minus e raised to minus z divided by e raised to z plus e raised to minus z, where again z is nothing but our input linear combination of the input value to that neuron. And this tanh function basically gets the value between -1 to +1. Basically this is also used to get the data or the values between -1 to +1. in which basically we are getting all the polarity, like we are considering the polarity of data. Then we have rectilinear unit of which is an activation function again. And this is a very interesting function because rectilinear unit helps us to serialize the output and reduce the linearity in the data or in that data. So we have whatever is the linear combination, what is the input data, uh, we are going to find out maximum of 0 comma z. So 0 is the value if in case the z or the linear combination of your input data z value, if it is negative, so it will consider 0 as the value. So basically the output of a rectilinear unit is also going to be 0 and 1. But understand one thing, this is not going to be an sigmoid. It is not similar to a sigmoid. Sigmoid is different, where it calculates the value and based on the information in that data, it gives the value 0 and 1. It scales basically the value based on the formula which is given, and here it just finds out if the data is greater than 0, less than 0, it is going to convert the data into 0, and if it is greater than 0, it will keep it as it is. So this is how a activation functions are in this. These are the three important activation function. And why we need activation function? So the purpose of activation function is to introduce non-linearities into the networks. Now what is non-linearity of a network? So let us first understand what is a linearity in an prediction or in a prediction operation on in any kind of operation. So linearity basically, when we are trying to consider certain things in a certain way, like pre-assumptions. So linearity indicates pre-assumptions, considering that if this is going to happen, this is also going to happen. Okay, such kind of assumptions are good to do predictions, like it helps us out to do the prediction. But when we have cases when we do not see any linear dependence of the data over each other, in such situations the algorithm will fail if we are considering the linearity part. Okay, so we need to introduce certain level of non-linearity so as the algorithm doesn't try to build up a linear combination all the time. It will also consider non-linearity over the dependence of input and output data, and that is why we require activation function. Activation function reduces the non-linearities. Activation function reduces the linearity, and that is how the model will now the new learning algorithm will now not have any pre-assumptions. It will not be biased at all. It will be considering everything as a new situation, and based on that new situation it will keep on changing all the time. So if we wanted to build a neural network to distinguish the point, as we can see here, we see that there is no linear separation between these 2 points. If we assume, like we can see that there is a polynomial kind of separation like this, but there is no linear combination or separation of data. A single line cannot distinguish between the data. So in such situations, the neural network may fail, and that is why we require activation function, which can help us out to reduce such kind of anomalies while predictions. So for that we require the purpose of the activation function is to introduce, as we know, that non-linearity. A linear activation function, as we see that it is not able to clearly distinguish between the red and the green points, but when we see about this non-linear separations of data, it will definitely build up a separation where it will clearly tell us what is green and what is red category. So this is how it will help. This is how the activation function helps us out to get separation. And here we have certain activation function. First function that you can see, that is unit step function, and uh, it is also useful. We can see per unit step function, the graph for the step function is given like this. As we can see, step function basically is something where we give a bias over that particular value. Like if the value is 0, we will have the value as 0.5. If the value is 1.5, it will get the value as 1. Like we are just giving a bias just above that particular input data. Then we have signum. Signum is a function where we are getting the values like this. -1 to 1 is the value for this activation function, and here also it is an perceptron variant. You can see the values are coming as -1 to +1. Then we have linear separation. Linear separation, we have the example is Adeline, and linear regression lines are basically this linear separations of data. Piecewise linear, where we have support vector machine, where we can see separation not just in a single line vector, but yeah, if we can have a multiple separation levels of this line. So these are piecewise linear regression. Then we have logistic or sigmoid activation function that we have discussed just now, which has the values like 0 to -1, and it is always in a form of sigmoid activation function. And sigmoid activation function is very commonly used because it helps us out to clearly separate out the data based on a probabilistic value or a logarithmic value. Then we have hyperbolic tanh function. Now, hyperbolic time function is a multi-layer neural. It is used in multi-layer neural network, and it basically gives us the value between -1 to +1, but it gives a value based on the input data that is passed onto it, and very commonly used in neural networks and useful as well. Now, we will talk about a three-layered neural network, as we can see here. So, in this neural network, we have three layers. First is the input layer, then we have hidden layer, and then we have output layer. Now let us try to understand what is happening in each of this layer at the neuron level. So at a neuron level, you can see there is a input coming to 1 as 0.9, 0.1 and 0.8. I will be discussing about only the neuron 1 over here and what is happening. So this neuron 1 is getting three inputs, that is 0.9, then it is getting 0.1, and it is also getting 0.8. Okay, so if we talk about this neuron 1, this neuron 1 will have certain activation function which will process out the information, and this information is passed on to the new hidden layer. It can be passed here, here as well as here. It is passed to all three neurons if it is fully connected, and all these three neurons will have information from each of this neuron like this. And again, the same thing is going to happen for the third neuron as well, third input layer as well, and it will process the information and it will transform the output in the next output layer. So what is happening here is the weights that we are going to decide here, weight for 1 comma 2 and weight for 2 comma 1 and weight for 2 comma 2 is weight for 1 1 and weight for 1 2 and weight for 2 1. Basically all these three weights are kind of all these three weights are kind of getting over this input layer, and this input layer process out the information. Now when we talk about multiple neural networks, each neuron becomes a judge. Each neuron has its own weights and biases, and it has its own activation functions. Activation function can be same in a single layer, and based on that activation function, but the input value is also going to be same, but the weights are different for each neuron in that layer. And based on the weightages and importance given according to each and every neuron, it will adjust or the output will be different, and this output is shared over the next hidden layer. Now this hidden layer becomes a very deeper level analyst. It analyzes the input or the output. It analyzes the output given by each of this layer 1, 2 and 3. Now due to that, what happens is this output information, when it is processed, we have a second level of verification or processing the data, and this will go to the layer 3, and similarly it will go for layer 3 from each of the output. And this level 3 output, we have probability value, we will have different probability value 0.4, 0.3 and 0.3, and based on these values we will decide in which category this particular data actually lies. So based on this, we decide whether in which category this data point lies. So multi-layered neural network will always have this feature of having multiple layers, and each layer will do the processing at every neuron possible. Layered neural network. So let us take the input of depth ratio and assume random weights from the nodes. So input 1 is 0.9, 0.1 and 0.8, And the input which we are talking about, which is then hidden input, it is going to be 0.9, 0.3, 0.4 from the first layer, then 0.2, 0.8, 0.2, 0.1, 0.5, 0.6 as the values. So we have passed only the values 0.9, 0.1, 0.8, but in the input hidden layer, you can see there are multiple inputs now for the weights, because each weight will be associated with the each neuron as it is connected with the next layer. And the hidden input for the next layer, or the hidden layers output, weight output, is going to be 0.3, 0.7, 0.5. So we will assume the random weights here, and initially it is always random. And the output at the first node is the input to the hidden layer, and this is what is happening here. So x hidden is equal to w input hidden into I. So this is at the first neuron level, or the first layer of this neural network, and these random weights are multiplied with the input values, and we will get an output value for each and every neuron. Okay, now these neuron will transform the output to the next hidden layer. For example, here the O hidden layer, the hidden layer where we apply the sigmoid activation function on the hidden layer output, and whatever is the output that we have received, the sigmoid activation function is applied over it, so as to get values as 0.761, 0.6, and 0.6. Now these three values are the output of the hidden layer, and as this output is received to the output layer 3, which is the output layer, and this output layer again has three different level of input hidden layer, or the weights, and these random weights are again multiplied with this output of this hidden layer. So when we multiply this, we get some values like 0.97, 0.88, and 1.254. Now again, for the sigmoid activation, to pull the output from the output layer, we apply the sigmoid activation function over the output layer, and on this, after applying the sigmoid activation function, it converts the value on a scale of 0 to 1, and we get the value 0.726, 0.7, and 0.778. Now as we can see, there are three outputs over here, and based on this output, the category of that data is decided. So as we can see, it is in the first category, so it will be considered into the first category of the data. So if we talk about all three layers, each layer is doing what? It is taking some random weights, it is multiplying that weight with the input value, and once the output is received for each neuron, this output is passed on to the next layer, where this next layer will also have the random weights. This output of the first previous layer, as well as the weights of the current layer, will get multiplied, and then we applied an activation function based on whatever level of hidden layer, or whatever layer it is. So if it is an hidden layer, we will apply ReLU activation function, or rectilinear unit, and this rectilinear unit, when we multiply it with the data, so it will get transformed to some other level, and as it will also create an output of vector. This output vector is passed on to the last, or the output layer, as we have only three layers over here. The output layer will multiply the data with the weights, and as it is multiplying, these weights are again random weights, and when we multiply this, it will again create an output, and on that output we apply the activation function, which is the sigmoid activation in our case right now. And this sigmoid activation function will cover this data, or convert this data into either in the form of either into a value of 0 to 1. So this is how entirely the phenomenon of a neural network computation happens.